In this tutorial, we're going to talk about section 2.3, piecewise functions. The reason why these functions are called piecewise is because they are broken down into pieces. So let's take a look at our first example. So as you can see, in this function, we have two separate pieces. The first piece right here in red says that I'm going to graph the function x squared for all x values less than or equal to 2. The next part, or the next piece of this, is here, and we're going to graph the function 6 minus x for x values greater than 2. Now, the idea from way back in the day of using open circles and closed circles is going to come back. We use an open circle if we have greater than or less than, and then we use a closed circle for less than or equal to or greater than or equal to. So the way that I like to start this off is I almost make a table for each piece of my function. So because I labeled the first one in red, I'm going to do the table for that part in red as well. So x, y. Let's go ahead and pick some values that are less than or equal to 2. So I can pick -2, I can pick the number 0, I can pick 1, and most importantly, to include the number that this domain goes up to, which it says is 2. So I'm going to plug each of these values in. So -2 squared is 4, 0 squared is 0, 1 squared is 1, and 2 squared is 4. I'm going to go ahead and plot those points in red on my graph. So -2, 4, it's going to go right here. And 0, 0 is going to be right here. And 1, 1 is right here. And then 2, 4, is right here. Okay. And so what we're going to do is we're just going to connect these. Now, what's important is that this guy right here, that point, is the endpoint of that function. So I'm only going to graph everything to the left of it because I only want the values that are smaller or equal to it. So this is the first piece of that function, and that's an arrow up there. So to do the second one, I'm going to get a table going for this guy, x and y, and I'm going to pick values that are greater than 2. Now, I know that I'm not including 2 in here, but I still need to know where that leaves off, so I have to choose 2 first. Now I'll just pick a couple values that are greater than that. We can try 4, I can try 6. Let's just stick with those. So when I plug 2 into 6 minus x, so 6 minus 2, that's 4. And 6 minus 4 is 2, and 6 minus 6 is 0. So this point right here, since the function says that it's greater than, that's going to have an open circle where that is. So at 2, 4, I'm just going to encompass this with an open circle. Now the next point was 4, 2, so that would be right here. And then my last point, 6, 0, right there. So I'm just going to connect those, makes a straight line, and there we have it. And that's my piecewise function. So let's take a look at another one. Okay, so here's my next function. There's 3 pieces to this piecewise function this time. I'm going to go ahead and get my color coding started. This one's going to be red, blue, orange. So for the first function, the x values that I can choose are x's less than or equal to -2. So let's pick, we'll try -4, I'm going to try -3, and then of course the endpoint that's included, -2. So when I plug these values in, let's see, -4 plus 4, well that's 0, -3 plus 4 is 1, -2 plus 4 is 2. So let's go ahead and graph that part of my function. And it's going to look like this. So because this here, negative 2, 2 was the end point, that's as far to the right as it's going to let me go. That's where my closed circle is, and that's this as far to the right as I can go, so that part's done. Now the next piece, the blue piece, says, okay, so my function is 2? Well, what does that mean? It means that no matter what value that you plug in for x, your y's are going to be 2. So my domain is between negative 2 and positive 2. They're going to be open circles. I'm going to go ahead and put negative 2 in here. Let's go ahead and pick one in between negative 2 and positive 2. How about 0? And then I'm going to pick my other end value, which is positive 2. Now, what this function says is no matter what I choose, everything is at 2. So let's go ahead and plot that line. So there it is in blue. So open circles at both ends. It's a straight, constant line. We're ready to go for the last piece. So here's my table for the last piece. So this time I have to choose only values greater than or equal to 2. So I'm going to start with 2, and I'm going to choose a couple values that are larger. I guess we'll choose 6, and how about 10? And I'm randomly picking these numbers. There's no rhyme or reason to them. I just have to make sure that I pick x values that make sense to the domain that I'm given. So 4 minus 2 is 2. 4 minus 6 is negative 2. And 4 minus 10 is negative 6. And this guy right here is going to be a closed circle. So let's go ahead and plot that. And there we go. So closed circle, we have an arrow at this end because this is going to keep on going forever, and an arrow at the other end on the left because that keeps going on forever, and that's my piecewise function. What we're going to look at next is how to actually write a piecewise function when we're given the graph. So let's take a look at that. Okay, so here we go. So in this graph, as you can see, we've got two different pieces. We have this red line, including the points negative 6, 5, and 1, negative 3. And we have the blue line, which includes the points 2, 3, and 9, 6. So if I'm supposed to be writing the rules for these lines, I have to know how to find the equation of this line. Now, what we're going to have to remember is our trusty old point slope and slope intercept forms. So slope intercept form is y equals mx plus b, and point slope form is y minus y1 equals m times x minus x1. All right, so for the red line here, if I were to write the equation of the line, I have to know my slope and my y-intercept. And based on this picture, it looks like it's pretty easy to tell where the y-intercept is. It looks like it's at negative 2. So I say let's just go ahead and use our slope-intercept form. And before we do that, we have to determine what the slope is. So if we do rise over run here, let's see what's the difference. I'm going to start at 1, negative 3. At negative 6, 5. And I have to go down. I have to go this way to get here. So I went down, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 8. So I'm going down 8, and then 1, 2, 3, 4, 5, 6, 7. So my slope here is negative 8 over 7 x. And the x is not part of your slope, but it's the coefficient of x. And then my y-intercept, it looks like, is negative 2. So now we have to set the domain for this. What x values does this function apply to? And it looks like the farthest to the right this function goes is up to x equals 1. This guy right here. And it looks like because the circle here is closed that I can include that. So this is going to be x is something of 1. And it looks like I can choose all the values to the left of 1, so that means x is less than or equal to 1. So any value less than 1, that red line should cover. Now what about for the blue line? I don't necessarily know where that function is going to cross that y-axis. I have no idea. So what we're going to have to do is we have to use our point-slope form. And what point-slope form says is I need a point for y1 and x1, and then I need to know my slope. Well, if you remember from way back when, if I wanted the slope between 2 points, all I got to do is y2 minus y1 over x2 minus x1, if you so choose. Because we have a picture, we can just figure this out by following the dotted lines. So from 2, 3 to 9, 6, I have to go up, and I have to go up 1, 2, 3. So I'm going up 3 and over 1, 2, 3, 4, 5, 6, 7. So my slope here is 3/7. Okay, so now we have to use our point-slope form to help us out finish this. So I'm going to go ahead and get this set up. So y minus y1. I'm going to go ahead and choose the point that I like the most. I'm going to choose 2, 3 because the numbers are smaller. And the y value there is 3. So y minus 3 equals m, which stands for slope, which I just determined to be 3/7. And then x minus x1. So the x value that goes along with 3 was 2. Okay, so now I'm going to distribute the 3/7. So y minus 3 equals 3/7 x, and this is 2/1, so negative 6/7. All right, we're almost to the end, so I'm going to add 3 to both sides. So what this is going to give me, and I have to make a fraction out of this, if I add 3 to 6/7, if that were in terms of sevenths, that would be 21/7. Think about it. What is 21 divided by 7? It's 3. So it's the same exact thing. So what is negative 6 plus 21? Or what is 21 minus 6? And the answer is 15. And then my denominator is 7. So this is the function for this. It's a good thing we didn't guess. Although it's very close to 2, it doesn't seem like it's 2 exactly. Okay, now for which x values does this incorporate? The farthest to the left this function goes is positive 2, and it does not include it. And I'm looking at the graph right now. And then I can keep going to farther values on the right. So I'm looking for values greater than 2. And the way that I write that is x is greater than 2. So just like that. And that concludes this tutorial.